Hi students, welcome to my lectures. In my previous lecture, I have given overview of what we are going to learn. In the first phase, we are going to learn PVT estimations, pressure, volume and temperature estimations for liquids as well as vapors. There are separate set of equations and procedures for the estimation of volume from the pressure and temperature data. Those are called, there are equations of state and cubic equations of state and generalized correlations. For liquids, this set is available, and for vapors, we have another set of procedures and equations that are existing. Which one is the first one is ideal, virial equation, cubic equations of state like Van der Waal, Redlich, Soyev, Epping, Robinson's, and the generalized equations of state. Okay, and there are generalized correlations exist. Okay, to find out volumes, okay, volume of the vapor or liquids for a given pressure and temperatures. So before we go into the pressure, volume, temperatures, we should able to find out what are liquids and what are vapors. Are we how can I can able to identify whether I am calculating volume for the liquid or volume for the vapor. So to do that, there is a basic understanding is necessary. The basic understanding necessary can be learned through volumetric properties. So the volumetric property of the fluids. In the first stage of the volumetric properties of the fluids, there is a graph which is pressure and temperature data. It's called P and T graph, PT graph. So to understand thermodynamics, it is always it will get simplified if you can imagine a substance which is present in the piston and cylinder assembly. So there is a certain amount of substance is present. The pressure can be measured through the pressure indicator, volume can be measured through volume indicator, temperature can be measured through the thermometer, and here you can able to supply some amount of heat. So because of the supply of the heat, the substance which changes its phase from solid to liquid, liquid to vapor. So the transitions of the different phases can be identified and be plotted on a particular graph. That means observe the P and T, that is a combinations of pressure and temperature where it is solid, and combinations of pressure and temperature where it is liquid, combinations of pressure and temperature where it is vapor. Okay, if you can able to plot that means if I can able to conduct the experiment at different high pressures and different temperatures, I can able to plot this P and T graph. So pressure I can increase and decrease using some weights, or I can able to maintain some vacuum conditions in this chamber. So I can observe the different phases. Okay, that's a schematic. It is just a schematic that we can able to observe the different phases of this substance in this particular piston and cylinder assembly. So if I plot the pressure and temperature values on the particular graph, I can able to get information that I get some areas where I can, if you maintain the pressure and temperatures over this particular region, it's called the solid. And if you maintain the pressure and temperatures in this particular region, it will be a liquid. If you maintain the pressure and temperatures over this region, it's called the vapor. So transition from solid to liquid. Okay, we can able to identify a line which is separating the solid and liquid. That means if you can able to maintain the temperature and pressure on this particular line, that means you are trying to look into the conditions where a substance is transferring from solid to liquid. If you observe, that is called the fusion curve. If you can able to observe this particular line, that means you are identifying the temperature and pressures on this particular line where you are going to see the transitions from liquid to vapor. So similarly, if you are able to observe this particular line 1 to 2, it's called the sublimation curve. That means you are identifying in temperatures and pressure conditions where a solid is transformed to the liquid. That means 1-2 line is indicating solid to vapor or vapor to solid. 2-3 line is the 1-2 line is called sublimation line curve, or 2 and 3 curve. That means it is representing the transitions from solid to liquid, and 2 and 4 it is representing liquid and vapor curve. So all the three curves meet at one point, which is at 2, the sublimation curve, fusion curve and vaporization curve all meets at one point, which is called triple point, PT and TT. Okay, that means at this triple point, that means if you maintain this particular pressure and this particular temperature, inside there will be solid, liquid as well as gas phase. It could be vapor, it could be anything, water, any substance, because this particular graph is a substance specific. Okay, if it is a water, the temperature and pressure combinations will be different. If it is ethanol, butanol, different substances have their own PT graph. Okay, and in our subsequent part of the thermodynamics, we will be concentrating on this particular line. That means in most of the chemical engineering applications, we have to deal with liquid and vapors. So the important thing we are supposed to concentrate is 2 and 2 to 4, which is called vaporization curve, because here on this side of the curve it is a liquid, on this side of the curve it is a vapor. Most of the applications we are trying to separation reactions and everything, we are mostly concentrating on liquid to vapor or vapor to liquid. So our point of concern is vaporization curve. Okay, this is the whole idea of PT curve. There is certain point which is this particular point, which is called TC and PC, which is called critical pressure and critical temperature. You are trying to maintain beyond the critical temperatures and pressure, and it is called fluid region. That means what is the fluid region? That means you have tried to maintain the temperatures and pressure higher. That means if you go beyond this temperature, critical temperature, if you go beyond this pressure, it is called the critical pressure. What is this particular critical pressure and critical temperature? For example, let us define the phase first. What is the phase? What is the liquid phase and what is the vapor phase? Okay, there is a definition. Okay, let us go through the definition. A phase is termed as a liquid if the vaporization results from reducing the pressure at constant temperature. So let us mark it. Okay, I am saying that, let us assume this particular point we are saying it is a liquid phase. What is the property of the liquid phase? If you reduce the pressure at constant temperature, if you try to reduce the pressure, the liquid will become entering into the vapor phase. That means this liquid will become a vapor. So then I can say that this is the liquid phase, because it will become a vapor if I reduce the pressure at this constant temperature. Then what I can say, vapor phase, a phase is termed as a vapor phase if the condensation results from reducing temperature at constant pressure. What is this? Let us say I am saying that on this side of the curve it is called the vapor phase, okay, or gas phase. So that means if I reduce my temperature at constant pressure, that means this vapor will become a liquid beyond this particular curve. That means a vapor and liquid, it has got certain properties. That means I can make it a vapor. If it is a vapor, I can make it as a liquid by reducing the pressure and reducing the temperature. So what happens beyond this point? I can say that means beyond this particular curve. That means I am taking about beyond this particular. That means here, if I say there is a substance that is present here, if I assume that this substance is a liquid, okay, if it is a liquid, reducing the pressure it should convert to vapor, but it will not become a vapor. Assume this particular substance at this particular temperature and pressure is a vapor. If you reduce the temperature, okay, it will not become a liquid. Neither this point at this point, reducing the pressure will become a vapor, or reducing the temperature it will becoming a liquid. Both will not happen. If that particular point, it's called the fluid region. In general, air, okay, if you take it as generally air in the atmosphere, it is not easy for we can condense the air, because air, it is a supercritical fluid. Okay, we are not into the fluid region. Our entire point of concern is this particular curve, vaporization curve. That means I am dealing with the liquids and vapors. Now I hope you understand that what is the fluid. There is a critical temperatures and pressure, because this has the critical pressures and critical temperatures has an important role to play. So later on we can able to apply what is the importance of the critical pressure. I hope now you understand what is the liquid, what is the vapor, what is a gas, what is the fluid region, Okay, these are the things we have to identify in this volumetric properties of the fluids. So in the next part of the discussion, let us concentrate on this particular liquid to vapor phases, because we are going to expand this, but because we are going to apply all our knowledge of thermodynamics only for this particular part, liquid to vapor, vapor to liquid. So let us move on to the next lecture.